Okay, let's dive in. We've all, played around with AI, haven't we? You send a prompt to a chatbot, you get something back. Simple enough.
Right, a single interaction.
But what if AI could do more? What if it wasn't just one-off answers, but like a whole team working together, different AIs, specialized, collaborating?
That's exactly it. That's the core idea behind this agentic AI shift we're seeing,
Yeah.
moving beyond that single big AI model.
Yeah, towards AI systems that actually work together, like little autonomous humans.
Because real-world problems, well, they're not single prompts, are they? They're complex, multi-step.
Right. You need research, then maybe analysis, maybe talking to an API, processing documents. It's messy.
Things a single AI, however smart,
Yeah.
just isn't really built to handle end-to-end.
It's like needing a whole team of people, not just one super genius. You need the researcher, the analyst, the writer.
Precisely. And that human team analogy is central here. It applies directly to how we can structure AI collaboration.
And that's where these frameworks come into play, designed specifically to, well, orchestrate these AI teams. Today, we're digging into the source material you shared, specifically focusing on Crew.AI. We want to look at its vision, its architecture, how you actually build something with it, where it adds real business value, and where it fits in the bigger AI picture.
Yeah, our goal for this deep dive is really to get past the buzzwords.
Yeah.
We want you listening to understand what Crew.AI actually is, fundamentally.
How it works under the hood.
How it works, where it can genuinely help you, and what you need to think about practically if you're considering using it.
And honestly, looking through the sources, there are some really practical insights and, yeah, maybe a few surprising bits that could lead to some aha moments. So let's get started.
Okay, so the big picture first. This fundamental evolution. It's fascinating. We're shifting from these static models, text generators, image generators, to something more dynamic. Collaborative entities.
It feels less like just using a tool and more like building a little digital organization, a team of workers.
That's a great way to put it. And the sources really drive this home.
Yeah.
That single function AI, it hits a wall pretty quickly with complex, multi-step, real-world stuff.
Right, you're asking one agent to be a jack of all trades.
When you really need specialists. And specialists, well, they almost always outperform a generalist stretched too thin.
Makes sense.
So the key insight, the sources argue, is that the real enterprise value isn't just in the raw LLM intelligence itself that's becoming, frankly, more commoditized.
Okay.
The value is in orchestrating that intelligence, getting these models to work together effectively across a whole process, start to finish. It's moving from thinking AI as a brain to AI as an organization.
Or a workforce, yeah.
Yeah.
And this is exactly where Crew.AI positions itself, right? The sources describe it as a major open source framework specifically for this orchestration job.
Right, getting these role-playing autonomous AI agents to act like a cohesive team.
And it's apparently gaining traction pretty fast. Mentions of Fortune 500 companies already using it or kicking the tires.
Yeah, adoption seems significant. So, okay, if you want to build one of these digital teams, what are the actual pieces? What are the building blocks?
The sources lay it out pretty clearly, using that human team analogy. They translate that structure into basically 5 key software components. Table 1 lists them out.
Okay, let's walk through them. First up, agents.
These are the individual workers, the digital team members.
Exactly. Each agent is, at its core, an LLM instance. But crucially, it's given a specific persona. And this isn't just a vague description.
No, it's structured. The sources emphasize role, goal, and backstory.
Right, role, goal, backstory.
Okay, pause there. Why that specific structure? Why is role, goal, backstory better than just, one big instruction telling the AI what to do?
It's about effective prompt engineering, really. The sources explain it makes it much more intuitive to define the kind of specialist you need. You set the role, like senior market researcher.
Okay.
You give it a specific goal for this particular task, like analyze Q1 sales data for anomalies, and then you provide backstory.
The backstory, like you're an analyst with 10 years experience, that kind of thing.
Exactly. That context helps the LLM really inhabit that persona. It leads to outputs that are much more focused, relevant, higher quality, and consistent. It's how you get that specialist behavior instead of generic generalist output.
Okay, that clicks. You're setting them up with a clear identity and mission. So you've got your agents. What's next?
Next up are the tasks. These are the specific jobs you assign to an agent.
Makes sense.
And a good task definition needs 2 key things. A clear description of what needs doing, and really importantly, an explicit expected output.
Defining what done looks like.
Precisely. Gives the agent a clear target.
Got it. Agents have tasks. Then, tools.
Tools are absolutely fundamental. They're the agent's hands and eyes in the real world, letting them go beyond their training data.
So, web searches,
Right.
databases.
Exactly. Searching the web, querying databases, using APIs, reading files, you name it. An agent is only as good as the tools it has access to.
Okay, agents, tasks, tools, what else?
The process. This is the strategy for how the team collaborates. How do the tasks actually get executed? In what sequence? How do agents share information? It defines the workflow.
The rules of engagement for the team.
You could say that, yeah. And finally, wrapping it all up is the crew.
The top level thing.
Right. The crew object is where you bring it all together. You define which agents are in the crew, what tasks they need to do, and the process that governs how they work together. The crew kicks things off, manages the execution, and gives you the final result.
So agents, tasks, tools, process, crew. Those are the 5 core concepts.
The building blocks, yes.
Now, the sources mentioned Crew.AI offers 2 different ways to orchestrate things, crews and flows. This sounds like a key decision point.
It really is. It reflects that different problems need different approaches. The cruise paradigm, which was the original way, is all about autonomous, collaborative intelligence.
This sounds like where that emergent, maybe unpredictable problem solving happens.
Exactly. It's optimized for situations where you don't know the exact solution path up front. Think creative work, brainstorming, deep research, complex analysis, where the agents need freedom to explore and adapt.
Like a design team riffing on ideas.
Yeah, the analogy used is a creative agency brainstorming session. It's dynamic, iterative, unpredictable sometimes.
Okay, so that's crews. What about flows?
Flows are the other side of the coin. They were introduced later, specifically for predictability, reliability, and auditability.
Ah, so when you need things to happen in a very specific, repeatable way.
Precisely. With flows, you get fine-grained control. You define the exact sequence, the logic, any loops, how state is managed. Think orchestrating API calls in a strict order, running data pipelines, ETL, or workflows in regulated industries where you need a clear audit trail.
It tackles that black box issue you sometimes get with pure autonomy.
Exactly. The analogy here is more like a manufacturing assembly line step A, then step B, then step C. Very defined.
And this seems really powerful. They're not totally separate worlds, are they? You can combine them.
Crucially, yes. This is a key feature. A flow can actually call a crew as one of its steps.
Oh, interesting.
It means you can build a predictable, structured flow for, say, 80% of a process. But when you hit a particularly complex or novel subproblem, the flow can hand it off to an autonomous crew to figure out.
Like a standard support process escalating a really weird issue to a specialist team.
Perfect analogy. The crew does its thing, figures it out, and hands the result back to the flow to continue the process. It lets you inject these pockets of agency exactly where you need them within a structured workflow. Table 2 in the sources has a good breakdown comparing crews and flows.
Okay, let's zoom in on that process component again. You said it defines how a crew collaborates. There are 2 main types mentioned.
Yes, the choice of process is really the strategic core of how the agents interact within a crew. The first and simplest is the sequential process.
Name kind of gives it away.
It does. It's very straightforward, like that assembly line again. Tasks run one after another, in the order you list them. The output from task 1 becomes context for task 2, output from task 2 for task 3, and so on.
So perfect for linear workflows where you know the steps,
Yeah,
research, then write, then edit.
exactly. Simple, predictable, efficient for well-defined sequences.
And the alternative is the hierarchical process.
Right. This one's more sophisticated. It mimics a manager-worker relationship. You either designate a specific LLM to act as a manager role, or even create a dedicated manager agent.
Okay, and what does this manager do?
Its job is to take the overall goal for the crew, look at the available worker agents, and dynamically break that goal down into subtasks, then delegates those subtasks to the right agents, waits for them to complete, reviews their work, and synthesizes the results.
Ah, so it adds a layer of planning and control during execution.
Exactly. It's designed for more complex problems where the best steps aren't obvious up front or where things might need to adapt on the fly. The manager provides that dynamic coordination.
But I sense a but coming.
There's definitely a trade-off, yeah. The sources are clear on this.
Yeah.
That manager agent has to think, plan, delegate, review.
More LLM calls.
A lot more LLM calls.
Right.
Which means increased latency, it takes longer, and increased costs because you're using more token.
Right.
So the sources explicitly call it an anti-pattern, to use a hierarchical process, for a simple task that could easily be sequential. You're just adding overhead for no real benefit.
So the advice is, start simple with sequential and only bring in hierarchical if the problem's complexity genuinely needs that manager's dynamic planning.
That's the best practice, absolutely.
Hmm.
Start sequential, upgrade to hierarchical only if necessary.
And they also mentioned a future consensual process being explored.
Yes, which hints at potentially even more complex and collaborative agent interactions down the line. Maybe voting or negotiation mechanisms, perhaps.
Interesting. Okay, let's switch gears to getting practical. If someone listening wants to try this out, how do they get started building a crew?
The sources give a pretty clear path. First, the basics. You need Python, version 3.0 newer. Then you install the Crew.AI package, usually with UV or pip. Standard Python stuff.
Okay. And they offer a way to structure your project.
Yes, and this is highlighted as a good thing. There's a command line tool,
Yeah.
Crew.AI create crew. Instead of just starting with a blank script, this command sets up a whole project structure for you.
Oh, like folders for agents, tasks?
Exactly. Folders for agents, tasks, tools, configuration files. It encourages good organization from the get-go, which is really helpful as your project grows beyond a simple script. Makes it more maintainable.
And a lot of the configuration defining the agents and tasks can be done in YAML files.
That's the recommended approach, yes, using files like agents.yam and task.yaml. The sources see this as a big plus because it separates the agent's persona, the task description, from the how, which is the Python execution logic.
Meaning someone less technical could potentially tweak an agent's role or goal just by editing the YAML.
Potentially, yes. It makes it more accessible. The examples in the sources show how clean this can be, defining a researcher agent or a research task, even specifying things like output file to save results directly.
Okay, so you've defined your crew in code and YAML. How do you actually run it?
You'll need your API keys, of course, for your LLM provider or any tools like web search. The standard practice is to put those in a .env file.
Right.
Then you just go to your project directory in the terminal and run Crew.AI run.
Simple enough. Can you make these crews dynamic, like run the same research crew but for different topics?
Absolutely. That's essential for reusability. The sources show using placeholders like topic in your task descriptions or YAML files.
Okay.
Then in your main Python script, when you start the crew, you use the kickoff inputs method to pass in the actual value for topic. You can even use kickoff for each with a list of inputs to run the same crew multiple times automatically.
And the results. How do you get the output back?
When kickoff finishes, it returns something called a crew output object. This isn't just the final text. It gives you structured access to everything.
Like what?
You get the final output in different formats, raw text, JSON, even a Pydantic object if you define one. You also get the individual outputs from every single task that ran, task output. And critically for managing costs, you get detailed token usage data.
Ah, seeing exactly how many tokens each agent and task used. That's huge for optimization.
Definitely. Very practical.
Speaking of practicalities, let's talk more about tools. You said they're the lifeblood of agents.
They really are. Without tools, agents are just, well, chatbots stuck with their training data. Tools let them do things in the world. Web search, database lookups, file access, API calls.
And Crew.AI has a set of ready-made tools.
Yes, there's the Crew.AI tools library. The sources mention it covers common needs. Web scraping tools, search tools, like integrating with SerpDev tool for Google Search, database tools, PG search tool for Postgres is mentioned, file I/O, and a whole set of urge tools.
Bargain retrieval augmented generation.
Right. Tools specifically designed to help agents pull information from documents, CSVs, PDFs, BDFs, JSON files, even searching code in GitHub repositories. It helps ground the agents in specific provided data.
The sources also mentioned something called the Model Context Protocol, MCP. What's the significance of that?
Ah, yes. MCP is positioned as a really strategic move by Crew.AI. It's basically an emerging standard, an agreed-upon way to define how tools should work and describe themselves.
Okay. And why is that important for Crew.AI?
By supporting MCP, Crew.AI agents can potentially use any tool built by the wider community that follows this standard without needing custom code for every single one.
So Crew.AI focuses on the orchestration framework and leverages the community to build out the huge ecosystem of tools.
Exactly. It's smart. It outsources a lot of the specific tool development. It also makes it easier for developers to switch to Crew.AI from other frameworks like LangChain, because if their tools are already MCP compliant, they might just work.
But what if you need to connect to your company's internal database or a specific internal API? You'd need custom tools then.
Correct. And the sources describe two main ways to build your own custom tools. For simple cases, if you just have a Python function you want an agent to be able to call, You can use the @tool decorator.
Easy enough.
Yeah, it just wraps your function, uses its name and docstring for the agent to understand it. For anything more complex, especially if the tool needs specific inputs, use subclass base tool.
Oh, okay.
This gives you more control. You can use Pydantic models to define structured inputs, handle initialization, etc. The example given is an inventory manager tool that likely connects to a company's inventory database, a typical custom tool scenario.
And for making these tools efficient, they mentioned async support and caching.
Yes, crucial for performance in real applications.
Mm-hmm.
Async support means a tool can perform its action, like a web request, without blocking the whole crew. Custom caching lets you store results from tools so you don't have to run the same expensive search or API call over and over again. Saves time, saves money.
Another efficiency technique discussed is using different LLMs within the same crew, the polyglot LLM idea.
Right. This is really powerful for optimizing both performance and cost. You don't have to use the same potentially expensive, super powerful LLM for every single agent in your crew.
So you match the model to the task.
Exactly. Your lead analyst agent, the one doing complex reasoning in your synthesis, maybe that one gets GPT-4 or another top-tier model.
Okay.
But an agent that just needs to fetch some data using the search tool, or an agent that just formats the final output, they might only need a much faster, cheaper model.
Could you even use a local model for some tasks? Via a llama or something?
Absolutely. The sources mention that possibility. Or using highly optimized, cost-effective models from providers like Cerebra's for specific tasks. You might have a mix. A powerful cloud model for reasoning, a fast local model for retrieval, a mid-tier model for writing.
And this strategic allocation can significantly cut down on overall token costs.
Hugely. You're using the expensive compute only where it's truly needed. The sources show conceptually how you'd set this up. You configure different LLM clients, and then when you define each agent, you just pass the specific LM object you want that agent to use.
Very cool. Okay, beyond tools and multiple LLMs, what other advanced features are highlighted for building more robust, production-ready crews?
Several key ones. First is asynchronous execution, but this time at the task level.
Wait, how's that different from async tools?
Good question. Async tools make the individual tool call non-blocking. Async task execution, set via async execution, true on a task object, allows completely separate, independent tasks within the crew to run in parallel.
So if I have 3 research tasks that don't depend on each other?
You can mark them all as async, and
Yep.
Crew.AI will try to run them concurrently. If task A takes 10 seconds, task B takes 12, and task C takes 8, running them sequentially takes 30 seconds. Running them asynchronously might only take around 12 seconds, the time of the longest task. Big time saver for parallelizable work.
Makes sense. What about keeping humans involved? Sometimes pure autonomy isn't enough or safe.
Exactly. That's where human in the loop is critical, especially for enterprise use. You can configure a specific task so that before it completes, it requires a human to provide input.
Like for approval or clarification.
Yes, for validation, approval, providing missing information the agent couldn't find, or resolving ambiguities. It's that essential bridge between the AI's autonomy and real-world accountability and control.
The sources also discussed a planning feature. What does that do?
This is designed for crews tackling really complex or vaguely defined goals. If you initialize your crew with planning, true, something interesting happens before any tasks actually run.
Okay.
A dedicated agent planner, often using a capable but maybe cheaper model like GPT-4 Mini by default, gets invoked first. It looks at the overall goal, the agents, the tasks, and it generates a detailed step-by-step execution plan.
Like a project plan for the AI team, created by an AI planner.
Exactly. This generated plan is then used to guide the execution, often by adding it to the task descriptions for the worker agents. It helps bring structure to complex problems, improves consistency, and reduces the chance of the crew getting lost or going off track.
And finally, what about when things go wrong? Error handling, guardrails.
Absolutely essential for resilience. The sources mention several strategies developers should build in, setting iteration limits on the crew to prevent runaway loops if agents get stuck.
Right.
Implementing robust custom tool error handling so that if one tool fails, maybe an API is down, it doesn't necessarily crash the whole process. The crew can potentially recover or report the issue gracefully, and potentially using validation agents.
A dedicated agent just for QA?
Sort of, yeah. An agent whose specific task is to review the output of other agents against certain criteria before the final result is produced. Adds another layer of quality control.
Okay, great features. Now let's talk value. Where does Crew.AI actually make a difference in the real world? What
Yeah.
kinds of business problems is it suited for?
The source is painted as a very general-purpose platform for automating knowledge work. Section 9 gives a whole list of use cases across different industries.
Marketing and content seems like a prime candidate.
Definitely. Automating that content pipeline is a classic example. Agent 1 researches, Agent 2 writes a draft, Agent 3 edits, Agent 4 creates social media snippets. You can use it for generating personalized marketing campaigns, doing SEO analysis, brand monitoring. Lots of possibilities there.
What about sales? Lead generation?
Yeah, building agentic sales pipelines. You could have an agent researching potential prospects online, another analyzing and scoring those leads based on criteria, and a third drafting personalized outreach emails for the sales team to review and send.
Takes away some of the grunt work for salespeople.
That's the idea. Free them up for higher value conversations.
Finance and analysis must be another big one. Data crunching.
Absolutely. Automating complex, data-intensive analysis. An agent gathers financial data from various sources. Another performs analysis or runs models. A third generates a report summarizing the findings. Think stock analysis, compliance checks, fraud detection, even automating expense report processing.
And for us tech folks, software development.
Yes, assisting developers. Agents could help generate boilerplate code, write unit tests based on existing code, help identify potential bugs, or even draft documentation. The sources mentioned someone built a crew that could generate a simple tic-tac-toe game from a prompt.
Okay. Customer service. Beyond basic chatbots.
Way beyond simple chatbots. Agents could analyze incoming support tickets to understand the real issue, intelligently route them to the right human team, search internal knowledge bases for relevant solutions, and even draft comprehensive responses for a human agent to quickly review, edit, and send. Makes human agents much more effective. And then there are more niche or novel uses popping up too. Generating custom travel itineraries, simulating user personas for product feedback, drafting complex project proposals, monitoring sensor data from manufacturing lines, tracking legal documents.
It really seems applicable anywhere there's collaborative, information-based work happening.
That's the core idea. If you can break down a knowledge work process into specialized roles and tasks, you could potentially automate parts of it with a crew.
Okay, but automation isn't always smooth sailing. The sources included a really important case study, didn't they? A kind of reality check.
Yes, the NASCOM L&T Technology Services case study trying to analyze 5G network logs. It's a fantastic, sobering example of where the ambition met the limits of the current tech.
What was the specific problem they were tackling?
Just the sheer scale of the data. They were dealing with PCIP log files, where just a few minutes of network activity could generate a 150 megabyte file. Billions of lines of highly technical data.
Wow. Manual analysis is impossible there.
Completely impossible. They needed automation to quickly filter these massive files and identify specific network events or potential issues.
And they tried to use Crew.AI for this.
They designed what looked like a sensible three-agent crew. One agent to handle the initial filtering of the huge log file, one to understand the user's query about what to look for, and a third to perform the actual analysis on the filtered data. Conceptually sound.
But it didn't work out as planned. What went wrong?
This is where the reality check hits hard. The biggest roadblock was token limitations. Even with powerful LLMs, the context window, the amount of text the model can consider at once, was just way too small to handle a 150 MB log file effectively. The filtering agent couldn't even properly load or process the data it needed to work on.
So the fundamental LLM tech just couldn't cope with that data volume.
Not for that kind of task, no. Another major issue was the complex log structures. These PCIP logs aren't simple text. They have very specific, nested technical formats. The LLM agents really struggled to parse this accurately.
They needed more specialized parsing tools, maybe.
Exactly. It went beyond the LLM's built-in capabilities and would have required custom, highly sophisticated tools that weren't readily available or easy to build. And they also ran into query ambiguity. Users would ask technical questions, but the agents had trouble translating those potentially fuzzy requests into the precise filtering logic needed for the logs.
So what's the big takeaway from this attempt? Don't try complex stuff.
Not necessarily don't try, but the lessons are crucial. A naive approach just focusing on the cool agent orchestration won't work if the foundations aren't there. You need to consider data privacy, security, how it will scale, the user interface, how the system will learn. But the absolute critical lesson: validate upfront if the underlying LLMs and the available tools are actually capable of handling the specific data, the scale, and the complexity level of your particular problem.
This 5G log analysis was what the sources called high complexity, high precision, right?
Exactly. And the technology at least as implemented, just wasn't mature enough for that combination at that scale. It reinforces the advice. Maybe start with projects that are lower complexity or require less precision.
Which leads perfectly into that strategic framework the sources provided, the complexity precision matrix, for picking the right kind of project.
Yes, Table 3. It's designed to help you avoid biting off more than you can chew, like in the 5G case, but also avoid projects that are too simple to provide real value. It uses two axes.
Complexity and precision. Let's break those down. What's complexity here?
Complexity is about the workflow itself. How many steps? How interdependent are they? Is the logic intricate? Does it require deep domain knowledge? High complexity means lots of moving parts, conditional logic, specialized knowledge.
Okay. And precision.
Precision is about the output requirements.
Well,
Does the final result need to be perfectly accurate? Does it need to follow a very strict format like specific JSON? How much room for error is there? High precision means the output needs to be spot on, reproducible, and probably machine readable with very low tolerance for mistakes.
and plotting projects on these axes gives you 4 quadrants.
Right. Quadrant 1. Creative assistance, low complexity, low precision. Think brainstorming, drafting initial ideas, summarizing text loosely. Simple crews often work well here.
Okay.
Quadrant 2. Structured automation, low complexity but high precision. Things like extracting specific data from forms, basic data transformations, ETL, generating output that needs to be in a strict format like JSON. Here, flows might be better, or simple crews combined with very precise tools and validation.
Then the higher complexity stuff.
Quadrant 3. Research and analysis. High complexity, but maybe low precision needed in the final output structure. In-depth market research, writing long-form content that involves synthesizing lots of info. This often calls for more complex crews, maybe multiple agents, potentially the hierarchical process.
And the top right, the danger zone.
Quadrant 4. Enterprise systems. High complexity and high precision. This is the toughest. Think complex decision support systems, processing sensitive documents in regulated fields where every step needs auditing. This likely requires sophisticated hybrid approaches using both flows and crews, robust error handling, strong validation, and almost certainly human-in-the-loop components.
And the strategic advice based on this matrix.
Start in Quadrant 1 or 2. Tackle the lower-risk projects first. Get some quick wins. Build your team's expertise with Crew.AI. Understand its capabilities and limitations in your context. Then consider moving towards the more challenging Q3 and Q4 problems, armed with that experience. Don't try to boil the ocean on day one. The sources even provide some self-assessment questions to help score potential projects.
That makes a lot of sense. Learn to walk before you run.
Yeah.
Okay, so the open source Crew.AI framework is great for building, experimenting, maybe tackling those Q1, Q2 projects. But getting this stuff running reliably and securely in a large company, that brings other challenges.
Absolutely. Security, scalability, manageability, compliance. These become paramount in an enterprise setting. And that's where the sources introduced the Crew.AI Enterprise Suite.
The commercial offering built on top of the open source core.
Exactly. It's designed to provide the infrastructure, tools, and features needed for production deployment and management at scale.
And they described it using a 4-pillar lifecycle.
Yes. Build quickly, offering things like a UI studio for low-code or even no-code building and testing of crews, making it accessible beyond just hardcore developers.
Lowering the barrier to entry.
Right. Deploy confidently. Providing managed infrastructure, deployment tools, handling scaling, and even auto-generating basic user interfaces for the crews you build.
Taking care of the operational headaches.
Track all your crews. A centralized management console, a control plane for monitoring all the crews running in your organization, seeing their performance in real time, debugging issues.
Visibility is key.
And finally, iterate to perfection. Tools for A/B testing, different true versions, incorporating human feedback systematically to improve agent performance over time, managing training data. It's about that continuous improvement loop.
And presumably this enterprise suite directly addresses those big corporate concerns. Security, integration.
That's the focus. Things like offering different deployment models, SaaS versus self-hosted factory for data control, providing security and compliance certifications, mentions of SOC2, HIPAA readiness, having connectors for common enterprise systems, and offering analytics for tracking usage and ROI. It's positioned as the bridge from a cool open source prototype to a governed, scalable production system.
Okay, let's pull back for the final stretch. Where does Crew.AI fit in the broader AI ecosystem? What are the big picture challenges and who are the competitors?
Well, the sources are pretty upfront about the state of play. They talk about a chasm between hype and enterprise reality. There's huge interest in agentic AI, but actual production deployment is still lagging.
Only about 11% estimated in production, most still experimenting.
Something like that, yeah.
Yeah.
Still early days for widespread adoption. And the roadblocks aren't just about the AI tech itself.
What are the big blockers then?
A lot are organizational and infrastructure related. Things like data maturity and silos, just getting the right data accessible to the agents securely is a huge hurdle in many companies. Integrating with complex legacy systems is another. And a major one is the lack of established governance and security frameworks within businesses, specifically for these kinds of autonomous AI systems. People are rightly concerned about data privacy, control, and potential security risks.
And even if you solve those, building these multi-agent systems well is just hard, technically.
It is. The sources touch on core technical challenges inherent to any large multi-agent system. The sheer complexity of coordinating potentially dozens or hundreds of agents communicating and depending on each other. Ensuring scalability and performance as usage grows. Just being able to observe what's happening inside observability and dealing with unexpected emergent behavior can be tough. And maintaining security and trust. How do you ensure an agent hasn't been compromised or isn't making bad decisions? These are hard computer science problems.
And when people look at frameworks for building these systems, Crew.AI isn't the only name out there. The sources specifically compared it to Microsoft's AutoGen. How do they differ?
They're presented as probably the two leading open source players right now, but with quite different philosophies. Table 4 summarizes it well. The core difference is Crew.AI is process-oriented.
Right, focused on automating known workflows.
Exactly. Its design, the whole agent task process structure, is built around defining and automating a sequence of steps using role-playing specialists. The sources say, use Crew.AI when you know how to solve a problem and want to automate the execution.
Okay, and AutoGen.
AutoGen is conversation-oriented. Its paradigm is different. It focuses on enabling agents to solve problems through conversation with each other. The solution often emerges from their dynamic dialogue and collaboration.
So it's more exploratory.
Yes. Use AutoGen when you don't know how to solve a problem and want a team of experts to figure it out for you through interaction. It's often highlighted for tasks involving complex reasoning, planning, or code generation where the path isn't predefined.
So Crew.AI for automating repeatable business processes, AutoGen maybe more for complex, one-off problem solving or research.
That seems to be the general distinction, yes. Other differences noted include AutoGen having stronger built-in capabilities for secure code execution, often using Docker containers, while Crew.AI relies more on external tools for actions. Crew.AI is generally seen as having a lower learning curve, maybe more accessible to business analysts, and has that clear enterprise strategy with the suite. AutoGen is often considered more developer-centric and started more from a research perspective, though it's also being used in production.
So not necessarily better or worse, but different tools suited for different kinds of jobs.
Exactly. And you could even imagine hybrid systems potentially using both in the future, leveraging the strengths of each.
Makes sense. Okay, finally, looking ahead. What's Crew.AI's longer-term vision? Where are they trying to go?
They seem to see themselves as building more than just a software framework. They're aiming to build an entire ecosystem. Section 15 in the sources kind of lays out their strategy, calling it a masterclass.
How so? What's the strategy?
It looks like a multi-pronged approach designed to build momentum and a defensible market position. Start with open source that builds a community, gets developers involved, drives initial adoption.
Standard playbook, yeah.
Then partner with educational platforms like their collaboration with deeplearning.ai. That helps standardize skills, creates tutorials, builds a talent pool familiar with Crew.ai.
Smart. Grows the user base.
Then offer the enterprise upgrade path. Capture the value from organizations that start with open source, but then need production-grade features, security, support. It leverages the bottom-up adoption to drive top-down sales.
Makes sense.
And finally, build infrastructure and go-to-market alliances with major players like NVIDIA, IBM, Cerebras. That lends credibility, helps solve deployment challenges like access to powerful hardware, and expands their reach. It's a layered strategy.
And product-wise, where are they headed? More features?
The roadmap mentioned focuses on enhancing the user experience, especially with that no-code, low-code UI studio. Broader integration with more types of LLMs, more advanced agent collaboration methods like that consensual process they hinted at, and really fleshing out that full platform vision. Build, deploy, track, iterate.
How do you see all this impacting the way we work? The sources mentioned project management specifically.
Yeah, it's a compelling example. The idea is that AI agents could automate many of the routine administrative tasks and project management, assigning tasks based on skills, optimizing schedules, identifying potential risks from data, tracking progress, maybe even allocating resources.
So the AI handles the grunt work.
That's the vision. Research cited from the Project Management Institute, PMI, apparently shows companies already using AI and PM see tangible benefits, better on-time delivery rates, better ROI, better realization of project benefits.
Does that mean human project managers are obsolete?
No, quite the opposite, according to this view. It augments them. By automating the routine stuff, it frees up human PMs to focus on the uniquely human, high-value tasks. Managing complex stakeholder relationships, making difficult strategic decisions, providing leadership and vision, handling exceptions.
So it shifts the human role towards strategy and interaction.
Exactly. The long-term vision painted is one of an augmented workforce where teams are composed of humans and AI agents collaborating closely. Businesses might start thinking not just about hiring people, but about assembling the right crew of human and AI agents for a given challenge.
And Crew.AI wants to be the platform that enables and orchestrates that new way of working.
That certainly seems to be the ambition driving their development, building the foundation for these hybrid teams.
Okay, wow, we've covered a lot of ground here. We really unpacked Crew.ai, its core ideas, the building blocks like agents and tasks, the difference between crews and flows, why tools are so vital, the strategy of using multiple LLMs.
And the advanced techniques like async execution, human in the loop, planning, and error handling.
Right. Then we looked at real-world use cases, but also absorbed that crucial reality check from the 5G case study. Learned how to pick projects strategically using that complexity precision matrix.
And saw the path to production via the enterprise suite, placed Crew.ai in the context of the broader challenges and competitors like Autogen.
And finally, touched on their ecosystem strategy and the potential future of human-agent collaboration.
I think the key takeaway is that Crew.ai offers a concrete, powerful framework for getting specialized AI agents to work together on complex, multi-step tasks. It's a practical approach to automating sophisticated knowledge work.
Definitely. While also acknowledging, as the sources did, the real hurdles that remain around data, legacy systems, governance, and just the inherent technical difficulty of truly robust, large-scale, multi-agent systems.
It's a field that's moving incredibly fast, though.
Yeah.
The tools and techniques are constantly improving.
So here's a final thought to leave you with. Thinking about this concept of human agent teams, this idea of assembling crews with diverse skills, how might you start thinking differently about tackling problems in your own work or your business or even personal projects? How could you combine human intelligence and specialized AI capabilities in new ways?
And if you want to dig into the specifics we discussed, those tables comparing crews and flows, the matrix, the code concepts, definitely spend some time with the source materials we base this on. There's a lot more detail there.